Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 24 of the June 2017 Algebra 1 New York Regents exam. This is a high-speed review tutorial. If you like to access the step-by-step solutions, or if you want to get access to the transcripts, just simply look at the description below to gain access to these tutorials. All right, let's take a look at question one. Question one has to do with the graphical representation of profits. Um, so if the question basically asks for what is going on the intervals from 10 to 40. Which graphical representation indicates a fall or a decline in the amount of profits? So you just have to remember that if a graph represents decline, the graph should be decreasing from left to right on that interval. So when you look at the four graphs provided, you want to focus your attention on 10 to 40, that domain, and look at the graph that's decreasing, going down from left to right from 10 to 40. And if you look at option 1, it's flat, is neither increasing nor decreasing. Option 2 is decreasing. Actually, option 3. So the correct answer is option 3. If you look at option 2, is increasing on that interval, and option 4 is increasing and then it decreases. The correct answer is the one that is just strictly decreasing on the interval from 10 to 4. So that's why our answer for question number 1 is option 3. All right, question 2 has to do with dependence and terms of a formula. The question asks what term in the area formula for a rectangular prism is independent or not dependent um, on the height. The area itself is dependent on the height because we have two terms here that have h in it. So the term out of these three, either 2LW, 2HW, or 2LH, that is independent, is the term that does not have h in it. And we can clearly see that the first term, 2LW, does not have an h, which means it is not dependent on the height. For question 3, we're looking at transformation of functions. We're looking at a radical function here. So if you know what a radical function looks like, you can easily see that the answer is 4. The radical function looks like a hook, okay? But let's talk about transformations real quick. You have the square root of x minus 2, so we have the parent radical function composed with x minus 2. So if you have f of x minus h, that means you're going to shift h units to the right. So since we have x minus 2 composed in the radical function, that means our hook function, our radical function, is going to be shifted 2 units to the right. And we can clearly see that this is the correct answer. Option 1, 3, and 2 are incorrect because we have a quadratic, and a linear function, which are not represented by the square root function. In question 4, we're looking at what's the meaning of the rate of change in this function represents. Okay, so you have to remember that the rate of change is basically the slope of a function over an interval. The equation that's given to us is the slope-intercept form of the equation of a line. So the coefficient of x, which is m, that's the slope. Okay, and the slope is going to be negative 0.09. That's also the average rate of change in that interval, which tells us two things. It tells us that it's going to be decreasing, and it is number of hours per age, per year of age. Now, how do we know that? We know that the slope is rise over run. The rise unit is average number of hours per day, and the run unit is age. So that's why we can clearly see that the answer is option 2 because we have decreasing, which is indicative of the negative we have here. And then if you look at the units, rise over run, the rise is average number of hours of sleep per day. That's your rise. And your run is the year, the age in years. So the answer is option number 2. In number 5, we're looking at evaluating functions at particular input values. So we have different answers provided here. So to figure out whose answer is correct, you simply plug in 3 into this function, and then you use the order of operations correctly, exponents first, and then you multiply and add, and you get 14, and that's the answer that Lynn had, so that's why the answer is option number 1. Okay, and then question 6 is testing our ability to factor. And we're going to be using the difference of squares formula extended to the difference of 4th-degree polynomials. All you have to remember is when you have the difference of two terms that have even powers, you simply take the square roots and then you express the roots as sums and differences. Okay, so when we take the square root of 16x to the 4th and 64, we get 4x squared and 8. So we just express that as a sum and a difference. And our answer for number 6 will be option number 3. Okay, number 7, we have a graph provided, and we are actually expected to select the correct equation that represents the graph. So if you take a look at the graph, it looks like an exponential function. So just based on the look of the graph alone, you can easily guess that the answer is option 1. Option 2 is a linear function. This is definitely not a straight line. Option 3 is a quadratic. It could be. And then option 3 is a cubic function. So the way to determine for sure that our answer is option 1 is to test the input values 0, 1, 2, and 3. I tested 0, 1, and 2, and I got 4, 8, 16, which matches perfectly with the y coordinate values for this exponential function. So we know for a certainty that our answer is option number 1. In number 8, we are solving a system of equations. So the second equation requires a distribution of 3 across just the terms to the left side. And then we have the system of equations 1 and 2 here. Now, since the first equation is solved explicitly for y, that's a hint that it will be beneficial for us to solve this system using the substitution method. So if you plug the value of y, which is 2x plus 8, into the second equation, and you solve, what happens is that the variables cancel out completely, and you end up with a false statement. Anytime you're solving systems of equations and the variables cancel out and you end up with a false statement, that means that there are no solutions to the system of equations. Basically, the two lines never intersect, okay? But on the flip side, if you have a true statement, that means that you have infinitely many solutions the two lines overlap. Okay, so the answer to number 8 is option number 1. Okay, number 9, we're given a map representation of a relation, and we have to determine if the mapping is a function or not, and what the reason is as to why it is not a function, or if it is a function, why. So you have to remember that functions assign every input to exactly one output. So you want to focus your attention on the inputs and see how many outputs they're being assigned to. January is assigned to 1, which is good. February is assigned to 2 outputs, 28 and 29. That is not good. Because February is assigned to 2 outputs, that violates the definition of a function. Hence, this mapping is not a function because of the reason stated in number 3. February has 2 outputs, okay? Functions assign one input to exactly one output. So an output can have 2 inputs, but an input cannot be assigned to 2 outputs. All right, number 10 requires going backwards, trying to generate a function that has these zeros. So all you simply do is you assign x to these 3 zeros, and you work backwards. You set each part equal to 0, and then you multiply the left side, the quantities, and then you group them as a function, and then you have option 3 as a correct answer. So remember that when you set them equal to 0, and it will involve the signs changing sign. Okay, so like x minus 3, when you set it equal to 0 minus 3 becomes x plus 3. And as you can see, x equals positive 4. When you set it equal to 0, it becomes x minus 4. So keep that in mind that when you're looking for the function that generates zeros, if you have non-zero zeros, their signs will get flipped when expressed in its factored form. So answer for number 10 is option number 3. For number 11, we're setting up a system of linear inequalities. We have constraints on the hours worked and the earnings. Okay, so they have to work a maximum of 40 hours. Maximum means it can't be greater. So we have less than or equal to for the hours equation. And then we are using the formula for earnings, amount earned, which is equal to rate times time to set up the earnings inequality. So we have the earnings for mowing plus the earnings for gardening, which is the product of the hourly wage times the number of hours worked. The requirement is that the earnings should be at least. So at least means greater than or equal to, it can be less. Okay, so that is why our answer for number 11 is option number 1. All right, number 12 involves setting up an equation to find the output of an exponential growth situation. We have a discrete growth, and this problem is basically assessing your ability to convert the percentage to the correct decimal form before implementing the formula. So you have to remember that before you input your rate into the exponential growth equation, you have to convert it from percentage to decimal form first by moving the decimal point 2 places to the left, and then you add. Okay, if it were minus, that's decay. For growth, this is interest. Interest indicates growth. Your money is growing in value. That's why it's an exponential growth scenario. So don't forget to change your rate from percentage to decimal before you input it into the equation. Okay, so following those guidelines, our correct answer will be option number 2. All right, for question number 13, we are solving a linear inequality. So what you want to remember is that anytime you divide by negative, you want to switch the orientation of your inequality sign, okay? So in order to get x isolated, we subtract 47 from both sides. And then when we divide by negative 4, the inequality switches from less than to greater. Okay, so the question is, which of these values satisfy the linear inequality? Any number that's greater than 10 satisfies the inequality. 10 is not greater than 10. Only 11 falls into the number line interval that satisfies this inequality, which is a set of numbers that are bigger than 10. Okay? Negative 13 and negative 10 are way less than 10, so they do not qualify. And that's why our answer for number 13 is option number 4. All right, number 14 is talking about the strength of the correlation between a data set. So what you have to remember is that the closer the correlation coefficient is to positive or negative 1, the stronger the relationship. So if the correlation coefficient is very close to negative 1, then it's a strong negative correlation. And as indicated here, as if it's really close to positive 1, that indicates a strong positive correlation. If it's close to 0, then there's no correlation. So basically what we're doing is we're looking at these numbers and we're asking ourselves which is the closest to 1 or negative 1. Okay, and 0.9 is zero point 0.1 units away from 1, and negative zero point 0.8 is close, but it is zero point 0.2 units away from negative 1. Zero point 0.9 is much closer, so that's why option 1 is a correlation coefficient that indicates the strongest relationship in the data set. All right, let's take a look at 15. A good way to attack this problem is just to graph the numbers on a number line. And you can look at the distribution right here. And if you determine what the median is, you find out that the median is 66. Okay, so the question is asking for which statement best describes the spread of the data. So the median being 66 is not an answer, so we can eliminate that. Now the question is, what do you notice about 79? Is way out of the range of the rest. So what does that tell us? It tells us that 79 is an outlier. Okay, and since it's an outlier, it is going to affect the standard deviation of the entire data set. So our answer for question 15 is option number 4. All right, so question 16, we're basically looking at the graph of a parabolic function and determining the correct equation or function that represents the graph that's pictured on the left. So we have the vertex as 15 and 25. So if the vertex is 15 and 25, we'll put it in the form ax squared ax minus h squared plus k, the vertex form. Remember, we do the opposite of the number for the x coordinate. Okay, so it's going to be x minus 15. So the x plus 15's options, those two cannot be the answer, okay? Because when you graph these, the vertex will be at negative 15 for the x coordinate. Now, if you take a look at the 3 and 4, this has to be, the correct answer has to be one of these options. Now, since the parabola opens down, it's like a sad parabola, like negative people. So since it opens down, that tells us that A is going to be negative. So we can clearly see that the answer is option 4 because we have a sad parabola opening down, negative, with the vertex of positive 15 and 25. So answer is option number 4. And another thing you can do to make sure that your answer is correct is just plug it in your graphing calculator, set the window appropriately, of course, and you see that the answer is option 4. All right, option 17, we have two functions. One is given in symbolic form, the other is provided numerically with this table. And we're asked about which of the following statements is true. We have intersections, axes of symmetry, vertices, and zeros. Now, if you take a look at the function itself, you can clearly see that the vertex is 3, negative. 3, 2 for f of x. And for the g of x, you have to inspect the table, okay? Now, if you inspect the table, what you notice is that you have a symmetry about 3, negative 5. So since you have a symmetry about 3, negative 5, that tells you that this is the vertex, okay? So for function g, the vertex is 3, negative 5, because you have negative 4, negative 4, negative 1, negative 1, 4, 4. Now the vertices have the same x-coordinate, but the y-coordinates are different. So the vertex cannot be the same. Now what is the significance of the x-coordinate of a vertex? The x-coordinate of a vertex represents the axis of symmetry. Now since they have the same x-coordinates, that means they have the same axis of symmetry. Answer for number 17 is option number 3. For number 18, you're given the recursive definition of a sequence of numbers, and you're asked which represents the range. So you have to remember that the range is the outputs, that's what you get out, and the domain is the inputs, that's what you plug in. All right, so when we generate terms of the sequence, what we're going to be getting is the range or the output values. When you start with the first one, you plug in 1 to get 2. Options 1 and 2 have 2 as the first output value, the first element in the set of the range. So we can just eliminate 3 and 4. Okay. If you want to determine the right answer, we just keep going. Okay. So the second term, you plug in 2 into this function. Now, since this is a recursive definition, you're going to have an F1 situation here, an F of 1. So in order to determine what that is, you have to go back to the term before it. F of 1 is 2, so that's what you plug in here to determine what f of 1 is. And then you simplify and you get negative 8. And we can clearly see that the answer is option number 2 because the second element in the set of the range values is negative 8. All right, for question 19, we have to find a solution to this equation with variables on both sides. So what we do is, first of all, take care of that parenthesis because it makes the problem look really complicated. So we distribute the 4 and the 0.3 appropriately, and then we want to have all the x's on the left and all the y's, I'm sorry, and all the numbers on the right side. Okay, so to simplify the whole process, I combine these two constants on the right to yield 2.71. And then I move the 28 to the right and then the 0.3 to the left. So we have 3.7x equals 30.71. To get x isolated, you divide both sides by 3.71. Just plug this into your calculator. You get 8.277. When you round it up to the nearest 10th place, your answer will be option number 1. All right, question 20. Looks like something you'll come across in physics or chemistry mainly, conversion of units. So when you're going from one unit to the other, the tip here is you want to configure the conversion factors in such a way that the starting unit gets canceled out and what you're left with is the target unit. Okay, the target unit for number 20 is number of hours. So you ask yourself which configuration enables me to cancel every unit and I'm left just with hours as the final unit. Okay, so if you look at this one, the first option, foot cube and load, they don't cancel out. The second one doesn't, the third one doesn't. The fourth one, see that cancellation happening? These two cancel out, the load cancels out, the minutes cancels out, and you're left with hours. So this is the option that will give us the desired result, which is the number of hours. So um, answer to number 20 is option number 4. Okay, 21 just is a an assessment of our understanding of what linear functions look like, their growth. So when you're thinking linear, you're thinking about constant growth over fixed intervals. Okay, so over a particular interval, you have the same growth happening over and over again. When you find the quotient of the um, change in the output values over fixed input values, that represents the slope. What do we know about slope of lines? Slope of straight lines are constant. Okay, so option number 21 is clearly option 3 because we have equal differences over equal intervals. All right, so that's your slope when you divide these two, you're changing y over changing x. When you're looking at factors, you're thinking about exponential functions. When you're multiplying by the same number over fixed intervals over and over again, you're looking at an exponential function. The focus here is on linear function. That is why we're looking at equal differences. Think about difference y2 minus y1, okay, over particular intervals x2 minus x1. Answer to number 21 is option number 3. Okay, 22 requires the use of completing the square. Of course, you can solve it using the quadratic formula, but the way it's set up right here, it's easier to just use the completing the square algorithm to get x isolated. So remember that when you're completing the square, you have um, perfect square trinomials that are not complete. So you have an imperfect square, like x squared minus 8x is not a perfect square trinomial. So to achieve perfection, you have to add b over 2 squared. Since this is an equation, whatever you add to the left side, you do the same to the right. b is b is negative 8, the coefficient of x. So you compute b over 2 squared, which is negative 8 over 2 squared, add it to both sides, and then you have a perfect square trinomial that you can easily factor by taking the square root of the first and last, bring down the middle sign. You have this perfect square equals 26. Roots both sides, don't forget plus or minus. And then you add 4 and you have 4 plus or minus root 26 as your final answer. The answer to number 22 is option number 2. Okay, number 23, we have a formula here, and we are asked which of the following are correct when you're solving explicitly for the indicated variable. So this problem might look scary, or I have to solve this formula 4 different times in order to find the correct answer, but it's not that bad if you closely examine what you're getting as you solve the equation. So for option 1, we have P1 isolated. To determine if this equation is correct, we have to solve the given function for P1. Okay, so to do that, you just multiply by R and add P2 to both sides. You have F R plus P2 equals P1, and that's perfect. For P2, you don't have to go back to the original format. You can start from the second step in 1, which is FR equals P1 plus minus P2. Now you subtract P1 from both sides since P1 is positive. This negative P2 over here, what you simply do is you divide both sides of the equation by -1, and the order of this difference switches. So instead of FR minus P1, you have P1 minus FR. That's what happens when you divide a difference by -1. The order of the difference changes. That's exactly what we have for 2, so this is correct. How about option 3? Is that correct? Continuing from the second step in option 1 or the first step in option 2, to get R isolated, we divide both sides by F. If you divide both sides by F, you get R equals P1 minus P2 over F. That's not what option 3 is. Option 3 is incorrect, so this is the formula that cannot be derived from this. If you look at option 4, it matches perfectly with what we got here. Okay, so answer to 23 is option 3. All right, 24 is basically assessing our understanding of the domain and range when you're dealing with projectile motion equations. So you have to remember that the domain is a constraint on the time that the object is in flight, and the range is a constraint on the height that the object attains during the flight. Okay, so if you want to find the boundaries on the time, basically when starting from when the object was launched to when it hit the ground, all you have to do is find the zeros of the height function. Okay, so that is why I set the function equal to 0, divide everything by -8, which is the LCD. And then if you factor out t and solve, you get two time values. T equals 0 is the launch time. T equals 3 over 2 is when it hit the ground. Okay, so the appropriate domain for this situation will be any time value from 0 all the way to 3 over 2, which is captured by 0 less than or equal to t less than or equal to 1.5. So the answer for option 24 is option number 1. Thanks so much for taking the time to watch this presentation. Really appreciate it. If the contents of this tutorial was helpful in your review of the scores that you got from your Regents exam, do give us a thumbs up. As indicated earlier, if you want to access the step-by-step explanation to the presentation, you can go to math.serve.com or go um, into the description. You find the link there. Don't forget to subscribe to our channel for updates to other tutorials such as this. Thanks again for watching and have a wonderful day. Goodbye.